Hello, this is Michael Sulak again with a video covering Chapter 7, which revisits the normal distribution. To go back over this, we're going to look at an example using two different random variables. And x is going to be the height of a randomly chosen woman, and y is going to be the miles per gallon of a randomly chosen vehicle. We have the height of a randomly chosen woman. So imagine that we sample a lot of women and we draw their heights. We might see something like this, where we would get a bell shape. Whereas if we sample a bunch of cars, the distribution of miles per gallon is going to look quite a bit different. It doesn't have a nice symmetry that height has. Lots of cars have low miles per gallon and few cars have high miles per gallon, making the shape of this distribution right skewed. So anyway, we talked about how we tend to represent the population of all women by taking this idea of a histogram and making it into a smooth bell curve. And we could do the same thing for all the 2017 vehicles. We could represent them with a smooth curve that's not symmetrical, that's right skewed. So it turns out that your height actually depends on where you're from. And I did some research. We're going to be talking about women specifically from the African country of Morocco. That's in the northwest corner of Africa. I've heard it's a lovely place. I'd love to go sometime. I found out that the mean height of all women in Morocco is 158.5 centimeters tall. And the standard deviation of their heights is 6 centimeters. And I actually know the same corresponding values with the miles per gallons of cars. The mean miles per gallon of all 2017 model vehicles is 34 miles per gallon. These are vehicles made in the United States, by the way. And the standard deviation is quite high, actually. It's 18 miles per gallon. There's a lot of variability in the miles per gallons of cars. Knowing this sort of information is useful because we might want to know questions like, what proportion of Moroccan women are between 5 feet 3 inches and 5 feet 6 inches tall? Or what proportion of cars get more than 30 miles per gallon? And I highly recommend, if you ever have a question like one of these two, to draw a picture of the curve and to draw a shaded area corresponding to the answers to these questions. Because our distribution of women, the parameters that we have for that are in centimeters, we would like to convert both of these measurements to centimeters. I know that, okay, this is talking about the area between 160 and 167 centimeters. And similarly with my vehicles, the answer to this question is the area to the right of 30 miles per gallon. So we have height on the left with its nice normal distribution, and we have miles per gallon on the right with its not so nice right skewed distribution. And it turns out that because miles per gallon does not have a normal distribution, we actually can't answer this question. We don't have the tools to know what proportion of cars get more than 30 miles per gallon. But height, because it's normally distributed, we're going to be able to answer this question. And to do that, we're going to use a function from our calculator called NormalCDF. And you find this function by hitting the second button, and then you hit the vars button, and the second one you see is NormalCDF. And the way this function works is it wants you to give it 4 numbers. Like with the binomial functions, we have to separate these numbers with commas. And these 4 numbers I tend to view in 2 different ways. The first 2 are going to tell us the area that we want to find, and the second 2 are going to tell us the distribution we want to use. The area ones, the first number tells us where to start, and the second one tells us where to stop. So for this problem, the area that we want to find is going to start at 160. So 160 needs to be the lower value here. And the stopping point for our area is 167. So that's going to be the upper value. We want to tell this calculator, this machine, to, hey, find the area under this curve. I want you to start at 160 and I want you to stop at 167. And actually, I'm noticing that my original value was 167.4. And then the third and the fourth numbers tell me what distribution I'm using. So the third number is going to be the mean of that distribution. And the fourth number is going to be the standard deviation. The mean here is 158.5, and the standard deviation is 6. And another thing is, when you're doing this, you need to make sure you have a clear screen. These computers are fairly particular. If anything is wrong, you'll get an error message. And that could be caused by things like having some numbers already on your screen, or from using the subtraction symbol instead of the minus sign, or from forgetting to use commas, or from putting a number in the wrong position. So when I do this in my calculator, if I round it to 4 decimal places, it's 33.45%. So what proportion of Moroccan women are between 160 centimeters and 167.4 centimeters? 33.45% of them. This area under the curve is also a probability. So I could have also been asked, what is the probability that a randomly chosen Moroccan woman is between 160 and 167.4 centimeters tall? And I would have done that the exact same way, and I would have gotten the exact same number. And so we can answer that question because height is normally distributed. Whereas this question regarding car miles per gallon, we cannot use that normal CDF function because miles per gallon is not normally distributed.